All right, so it says for the following scatter plot, interpret the type of trend the data set will hold. We either got positive, negative, or no trend. So here is our data. Okay, based on the way this data looks, what kind of trend does it have, Ashley? It has a positive trend. And why does it have a positive trend, Tyler? It's going up, it's increasing. Okay, so it's positive. Good. Number 2. It says a baseball coach graphs some data and finds the line of best fit. The equation for the line of best fit is this. All right, where this X represents the number of times at bat. That's what the X represents. And the Y represents the number of hits. Okay, so we know that when people are playing baseball, they don't always hit the ball every time they go up to bat. So those two values are going to be a little bit different. So the question says, how many hits? So what variable are we talking about when we're talking about hits? We're talking about the Y. Okay, so we're trying to solve for Y because it wants to know how many hits should he expect from a player who is at bat 175 times. What variable are we talking about when we're talking about being at bat? X. So X equals 175. Okay, I have a variable. I have an equation. What do? I substitute it. So I'm going to rewrite that equation. Y equals 0.32. But instead of that X, I'm going to plug in 175 minus 20.51. Okay, I'm just going to type all that into my calculator. 0.32 times 175 minus 20.51. Okay, so how many times was he at, or how many hits did he end up getting when he went up to bat 175 times? Here's the exact answer, but that would round to 35 hits. Okay, there's the work in case you need to make sure you got it all copied down right. Okay, there will be a lot of questions like this on your test where you'll be given an equation and be asked to estimate or predict given one of the variables. All right, this one wants you to describe the correlation based on the situation as either positive, negative, or no correlation or connection at all. So right here we have the number of people who watch a hit television show and the number of oranges sold at a grocery store. Okay, so let's say we all have the Bachelor on. So many thousands of people are watching The Bachelor, okay? Is that going to affect how many people go and buy a bunch of oranges at the grocery store? No, okay? So that has no correlation. Next, the outside temperature in the summer and the cost of the electric bill, aka air conditioning. Okay, what happens to the temperature outside in the summer? It goes up. Okay, it gets really hot. So what are we going to do with our air conditioners? We're going to turn them down, but we're going to have them running constantly, right? Now we're talking about the cost. What's going to happen when we're constantly running our air conditioning? It's going to go up. So we have our temperature going up. We have a cost going up. So what kind of correlation would that be? Positive. They're both increasing. Okay, there will be one or two like that on the test where you have you're given a situation like that and you have to determine if there's a correlation between them. What would the correlation between the number of hours you worked and how much money you get be? Positive. What happens the more hours you work? The more money you make, okay? The less hours you work, the less hours you make. So it'd be the same thing. So we have this data set here, and it wants to know which line fits it best. Okay, so it gives you these 4 options here. Okay, that one that you can't really see at the top is A. So looking at those 4 graphs, which line fits the data the best? Tyler? A is correct. We can see that the line goes straight through the center of the data. It's pretty evenly split on both sides. Okay, what's wrong with B? Why is that one not it? It's not even. It's all the data is below the line, so that's not it. Well, C looks like it's going straight through the middle of the data. What's wrong with it? Okay. Well, neither does A. It is going through the center of the data per se, but it's going through the center like here. It's not going and evenly like covering it on both sides. It's almost got too much above it here and too much below it there. It needs to kind of like tilt and go through the center of all of it. All right, and then D, once again, it's too far above it. There will be one similar to that on your test. All right, this one looks like number 2, I think. Almost the same exact question. It says a baseball coach graphs some data and finds the line of best fit. The equation for the line of best fit is right here. Okay, X is the number of times at bat, Y is the number of hits. It says how many hits. What are we trying to solve for? Hits, which is our Y value. Good. Should he expect from a player who is at bat 160 times? What variable are we talking about when we're at bat? X. So this time X equals 160. All right, I have an equation. I have one of my variables. What do? I substitute it. Okay, so that's what it looks like. I just instead of X, I substituted in 160. And I get 20.13 when I type that all into my calculator. Okay, so how many times did he actually get a hit? 20 times. Let's see. All right, next one. It says a student who waits on tables at a restaurant recorded the costs of meals and the tip left by single diners. Okay, so we've got our X values here. We've got our Y values there. It says using the line of best fit. Did they give us an equation for the line of best fit here? No. So what are we going to have to do? We have to go to Desmos. We have to create that line ourselves. Okay, and then it wants to know how much of a tip should the waiter expect to receive from an order that costs $10.50. Okay, so just to review, let's go and create this table into Desmos. Okay, I'm going to create table. Got 475. 684, 1252, 2042, 897, 0.5, 0.9, 0.5. All right, so there is our data. What is that little equation that we use to create the line of best fit? Who can tell me what that is? Abby. All right, we can see that that line goes straight through the center of all of my data. It looks pretty good. All right, and then if we want to come up with that equation, we have to use that slope and that y-intercept value at the very bottom. Okay, so if I'm writing this down, I'm going to put y equals on my paper. Y equals, we're putting it in that mx plus b format. So y equals the m value is what? It's kind of hard to see. 0.15. 0.16, you could round it, x. All right, what's my y-intercept? 0.30, what did you forget? It's negative. You've got to remember to put that or it'll change your whole problem. Okay, so you'd have to do minus 0.30. Okay, so that would be our line of best fit. And it said, how much tip? Okay, what variable are we talking about when we're talking about the tip? Y. Okay, so we're solving for Y. Should the waiter expect to receive from an order costing $10.50? What are we talking about when we talk about the order cost? X. All right, I have a variable. I have an equation. What do? You'd substitute it, okay? But since we already have all of it on Desmos, there is an easier way. You can just go down here. Since we already have that equation right there, I can do X equals 10.50. And that creates this vertical line here. And I just see where it intersects my line of best fit. So when my meal costs $10.50, which is the X, what is my tip? 1.35. Or you could have wrote it as that whole decimal that was on there. That says or. All right. Moving on to number 8. Okay, this was like the most asked question on the study guide, so you need to pay attention if you had questions on this. It says, the data given below shows the heights at various ages for a group of children. Given the best fit line as y equals 6.34, x plus 64.945. Okay. So it gives us all of these ages of the kids and all of their heights at those ages. Okay. And then the first thing it wants us to come up with is this estimated and predicted value. What do we use to make estimations and predictions? The line of best fit. Okay. So I want you to make a little mental note or just a note on your paper. Anytime we're talking about finding the estimations and predictions of something, we just need to ignore all of our y values at first. Okay, we do not need those to find the estimates. Okay, we just need our line of best fit. We need our x values. So we have an equation. We have a variable. How are we going to find the estimated heights? We have an equation. We have a variable. We're going to substitute it in. So in my calculator, I'm just going to do 0.634, but instead of x, what am I going to substitute it for? 18 plus 64.945. All right, so what's the estimated height for an 18-year-old according to this data? Okay, now we have to do the exact same thing, but now I'm looking at a 19-year-old. So for this, the only thing I have to change is I have to change that to 19, right? Okay, a really easy way to do that is just to use this arrow over here on your calculator, go up and highlight it, hit enter. It rewrote that exact same equation for me, and I just have to arrow over and make that a 9. This, since you have to do it so many times on this problem, it's really easy to start mistyping certain numbers, and that will change your entire answer. Okay, and it'll mess up the whole table. So that's a really easy way to not make that mistake. All right, so what's the estimated height when the person is 19 years old? 76.991. Okay. Here we are again. I just arrow up, highlight it, hit enter, arrow over to 0. Okay, what's the estimated height of a 20-year-old? All right, and you'll continue that same process for the entire table. I'm not going to do the whole table because of time, but that's just how you would continue doing that whole thing. Now, we have residuals. And when I first explained this, I told you to think back about like in elementary school when you would have those really large jars of jelly beans. Y'all remember that? Okay. And you'd have to guess how many jelly beans were in the jar. So how did they determine the winners of that? The one who was closest to the actual value. So you made a guess, and whichever guess was closest to the actual value, then you won. Okay. That's basically what a residual is. It's telling you how close a guess or an estimate or a prediction is to its actual value. So this is where the Y values come into play. How am I going to determine how close this value is to this one over here? Yep. Actual value minus the estimated value. Okay, write that down on your paper. That's an easy way to remember it. These are the types of things you need to write down and to study for your test. Okay, so for this first one, I have 76 minus 76.357. All right, what's the residual? Negative 0.357. All right, and just like if you were doing that jelly bean contest, how could you determine if something was a really good guess? Like say I had 500 jelly beans. What would be considered a really good guess? The number closest to 500, or the number with the smallest the guess with the smallest difference between the actual value, right? So a residual is good the closer it is to the actual value, or the smaller the difference. Okay, what would be considered a really bad guess? If it was the furthest away, right? Okay, so a residual is bad if it's really far from the actual value. All right, how am I going to do it for this one? How am I going to find the residual? Good, 77.1 minus 76.99. 1. All right, so I got 0.09. Oh my gosh, 0.109. And then finally I have 78.1 minus 77.625. And I get 0.475. All right, and obviously I would continue doing that same process all the way down. Okay, after we do the review tomorrow, I think that's not going to be as intimidating to y'all to have a question like that or multiple on the test. Obviously not to this large, but similar to this. Okay, number 9. Probably had a few questions on these, so let's talk about it. It says the scatter plot shows the price in cents of postage stamps used to mail a letter to the United States for the years from 1958 to 2014, also known as a line of fit to model that, blah, blah, blah. The equation for the line of fit is this. Okay, put a box around it, highlight it, do something because you need it. It's important. All right, in this equation, when we look at the Y, it represents the predicted price. So anytime throughout this problem, if they give us a price, it's representing the Y axis, and you can see that right here in the graph. All right, next it says X represents the number of years since 1958. That's important, and we'll come back to that in just a second. All right, so it says which statement best describes the slope of the model? That's the M value, okay? So they gave us this equation. We know when an equation solved for y, we can look over and which value tells us the slope? The one with the x. So what is my slope? 0.86. Okay, so since we know that's the slope, which ones can we automatically rule out in these multiple choices? Okay, A and B, right? Because those say 0.71. All right, now the slope tells us how our graph is increasing or decreasing. What's ours doing? It's increasing. So which one can we rule out now? D, because it says it decreases. So that leaves us with what? C. Definitely expect a question like that where you have to interpret the slope. So basically it's saying the model estimates an increase on average of 86 cents per year in the price of a stamp. All right, correlation coefficients. This was lesson 7 and 8. Okay, so the correlation coefficient tells you how strong or weak the data is compared to each other, okay? So this is when we were given that R value number and you had to put whether it was strong, weak, positive, or negative, right? Okay, so we talked about the closer the value was to 1 or -1, it was stronger. And then the closer the value got to 0, it was weaker. So right here is our R value, 0.994. That value is very close to 1, isn't it? So is it strong or is it weak? It's strong. All right, and also the fact that it's positive tells us what about our data? It's increasing. It's positive. Okay, if the R value is negative, that would mean our data was decreasing, okay? So the fact that it's strong means if we saw this graph, that the data is really clustered together, okay? If it was closer to 0, it'd be really spread out. Okay, so because it's strong, which ones can we automatically weed out? A and B, because it says it's weak. Okay, since it's positive, meaning all my data is increasing, which one can I rule out? C. It says it is strong, which is true. One variable is increasing, that's true. And the other variable is decreasing. Nope. So it would have to be D. It's strong, one variable increases, the other variable increases. That's true. C. It says according to the model, what is the best estimate of the year? What do we use to make estimates? The line of best fit. Of the year when the price of the stamp will first reach 75 cents. Okay, the price will reach 75 cents. What variable are we talking about when we're talking about the price? Y. All right, I even put a hint. Use the line of best fit. What is our line of best fit equation? Equals what? Okay, what is our, the one for this particular problem? What is our equation? They gave it to us at the beginning. We put a box around it. We highlighted it. All right, that is our line of best fit equation. We have an equation. We have a variable. What do? We substitute it. Be careful though. This one is substituting in for y. So that goes all the way over there. So my equation is 75 equals 0.86x minus 0.71. Okay, got to solve for x. We got to find the year. This takes us back to last unit. How do I get that x by itself? I start with the term that is furthest away. How do I get rid of minus 0.71? If I do it to one side, what happens to my 0.71s? Cancel out. What do I do here? Just add them together. 75.71 equals 0.86x. All right, still solving for x here. Got to get rid of the term that's paired with it. We did that by doing the inverse. So they're being multiplied, so we divide by 0.86. If I do it to one side, got to do it to the other side. So x equals 75.71 divided by 0.86. And I get 88.03. All right. However, none of the answers are 88. So why is that what we got? We did everything just like it wanted us to. Well, we have to remember what X stands for. X represents the number of years since 1958, not since 0. Okay, so we're not starting at 0 and counting up 88. We're starting at 1958 and then counting up 88. So we have to take 1958 and add 88 years to it. And when we do that, we get 2046. Okay, so what's our answer? C. There will be one similar to that on your test, so make sure you know how to do it. Okay, correlation coefficient again. It's the R value. If our data is more spread out, it is weaker. The R value is closer to 0. If our data is more clustered together, it is stronger. It is closer to 1 or -1. Okay, so out of these three, which one do you think is the weakest one? The first one, right? Why? It's all spread out. So at the very bottom of your page, we have 3 R values. So which one would that have to be? It would have to be R equals 0 because it's the weakest one. That's the only option it could be. R equals 0. All right, next. The next two, they both look pretty strong, don't they? What's the difference? One's increasing and one's decreasing, but they're still pretty close together. So we know they're strong. So we've got 1 and 1. All right, but this one's increasing. So would that be positive or -1? +1. All right, and then the third one would have to be what? R equals -1. Okay, here we go. We've got 3 or 4 R values up here. So I'm going to label these 1, 2, 3, and 4. And then I've got 4 graphs. We'll label those A, B, C, and D. All right, so looking at these 4 up here, the very first one I see is -0.09. Okay, so it's not only is it decreasing, and I know that because it's negative, but what value is it really close to? 0. So the graph is going to look really what? Spread out. Okay, so that's the smallest value out of all 4 of these up here. So which one of these 4 graphs is the weakest? A, right? Because it's the most spread out. Do y'all agree? All right, that R value is also negative, so we can kind of see that even though it's weak, that it's mainly going down, right? All right, so 1 would be A. Okay, done. Next, we have a positive 0.89 and a positive 1. So both positive and strong, right? Okay, so that's going to be either B or C, right? They're both strong, real close, tight together. Okay, between these two, which one do you think is stronger? B. Why is B stronger than C? It's closer to a straight line, right? C is more spread out. Not a lot, but it is more spread out, right? Okay, so B should be with what correlation coefficient? 1. So that would mean C would have to be what? The second one. And that leaves this last one. It's really weak. It's decreasing. So it would be negative 0.65. Okay, this one says which value represents the correlation coefficient rounded to the nearest hundred. So this one, they aren't just given to us and we have to match them. We actually have to calculate the correlation coefficient ourselves. And we have not learned how to do that mathematically because it is a very advanced like formula, okay? But I have shown you how to do it on Desmos. So it wants you to do that. So we're going to get that value on Desmos. So if it ever gives you a table and it has you find correlation coefficient, you need to think about this little hint right here. Step 1, create a table in Desmos. Step 2, find the line of best fit. Step 3, you'll have the correlation coefficient. All right, let's do that. We're almost finished. Stay with me. All right. So we've got our ages 20, 25, 30, all the way to 50. Heart rate. What do you notice about the heart rate the older you get? What's it doing? It's what? It's going slower. That makes sense, right? All right. How do I get the correlation coefficient? Is there a fancy little equation that we learned to type in to get it? Yeah, what is it? Same one to get the line of best fit. Okay, but instead of looking at these values down here, it just wants the correlation coefficient, which is the R value. Not to be confused with the R squared value. We just want this R value right here. So what is it? Nope. Negative 0.9991. Pay attention to the signs. So now that we have found it, what is my answer? A, negative 0.999. Not C, it's very similar, but that one's positive. Ours is negative because the heart rates are decreasing. Last one. It says the points in the scatter plot below represent the ages of automobiles and their values in dollars. Based on the scatter plot, it would be reasonable to conclude. All right, what do we know? Let's think about what we already know about cars, okay? You buy a brand new car. What happens to the value of it as soon as you drive it off the lot? It goes down, okay? If you buy a car for $20,000, 10 years from that date, you cannot sell it for $25,000, right? Its value decreases as it gets older. And you can see that graphically here. The age is going up. The price is going down, right? The value is going down. So it just wants us to describe that trend. Let's read the first one. As the age of the vehicle increases, the value also increases. Is that true? No. As the age of the vehicle increases, the value decreases. Is that true? Yes. All right, so it's not C, it's not D. Boom. That is your study guide. Let me